Thanks everybody for joining. My name is Trey Tyler. I'm a Senior Solution Strategist with OVH. Today's topic is how far is too far, the hybrid cloud distance factor. We'll just be talking about what it means to have a hybrid cloud and some of the things that come into play when it comes to how far is your cloud provider from your on-premise data center, either from a networking perspective or also just from building your cloud. So a lot of people, control is a big deal, so they might use a colo cage and put their own equipment in there because they want that type of control. So we'll look at those little things that might cause issues there, as well as just having people with the expertise to deal with your new cloud environment. A quick disclaimer for everybody. Everything in this deck is potentially subject to change. It's pretty standard boilerplate. We'll be talking about a few things that may or may not come at any given time period or anything like that, so don't hold us to it. We'll do a quick introduction. I know many of you, has anybody heard of OVH before? We've got a few hands. It's a company out in France, so we'll spend a few minutes to introduce everybody. So we'll start off from the ground level and give you some sort of foundation so you know what we're talking about as we move on, and then we'll look at the big the meat of the issue is the challenges of owning a hybrid cloud, and then what OVH can do to help out with that. And at the very end, we'll go ahead and do Q&A. Welcome to ask any questions. We'll have some folks walking around with the microphone. If you could ask your questions into the microphone so that we capture that for the recording, that would be helpful. So who is OVH? OVH is a global hyperscale cloud provider. We currently have, it's actually 27 data centers currently, and we're poised to build out to 50 data centers within by 2020. We currently have 1.3 million business customers, 32 POPs around the world, and we're predominantly in France. That's where we got our start back in 1999 is where we got started. We've been doing this thing for a while. We actually build our own data centers from the ground up, so we're not outsourcing or having somebody else build these things. The building itself actually serves as a function to the performance of the servers because we do liquid cool all of our servers. This is our own proprietary way of doing this. We build the vats, we have the tubings and a die that we put on the CPUs to run the cooling through that and then out to the vat to cool everything off. And then the way that the buildings are actually built are designed to pull air into the data center and then dump hot air out. So it does serve as a function. There is a purpose for that. So you'll walk in, it's really awkward because there's no AC units. It's kind of room temperature when you walk in. You're not used to just getting, you're used to getting frozen out, or being in the hot aisles and sweating while you're working on these things, right? OVH is a global, again, hyperscale provider. We do own the network between all of our data centers. We currently have about 11 terabits worth of backbone between all of these. Our data centers are set up with the 27 that we have now. We can support up to 1.3 million physical servers. I think currently we have about 270,000 physical servers actually deployed at this moment. We do build our own servers as well, so it's not just the data centers, and we build the racks that everything goes in. So since we have so much control over the entire process from the data center to delivery of the servers and everything else, we're able to tweak all of this and get the most efficient production as possible, which ultimately leads to savings for customers, right? So energy savings or just speed to deliver those servers. And the three primary services that we're bringing, at least in the US, these are all available here in Europe now, is our hosted private cloud, which is a vSphere as a service type offering. So many of you are aware of vCloud Foundation and being able to provide VMware as a service on all these different cloud providers. We've actually been doing vSphere as a service since 4.1, which was 2010. So fully automated deployment, the addition of hosts to an environment. It's really impressive. I think right now, if you needed to add a new host to your cluster, it takes about 5 to 8 minutes to add that in vSphere. If you lose a host for any reason, we'll automatically add a new one. So we've been at it for long enough that we've worked out and added a lot of additional features and functionality to make it easier to accept giving away control to a cloud provider. Public cloud is all built on OpenStack. So this product is primarily if you need to create a bunch of virtual machines to serve a purpose, scale up, you can use the Open API to do this, build 1,000 virtual machines, let them run, tear them down, do it again. This particular environment, you would not have control of the underlying infrastructure like you would in the hosted private cloud where you get access to vCenter. This is more of you create your virtual machines, but you don't see everything that's underneath, which is good too because OpenStack is pretty complicated to set up if you're going to build your own vein into that software. And then finally, the building block for everything is the dedicated servers. So if ultimate control is what you're looking for, go bare metal. Put your own operating system on there. We give you access via KBM through a Java applet or HTML5 on our webpage. You can access it directly and build everything custom to your liking. This is probably the highest performing type of product as well. If you need high performance and direct access to the hardware, that's the way to go. OVH again owns the fiber optic network between everything. All of these offerings are protected by our own homegrown anti-DDoS solution. I'll talk a bit about that. And private VLAN is talking about VRAC. So all of these different offerings in the same data center can be connected via the same VLANs. You don't have to put an edge and set up BGP between each individual environment. And we also have the capabilities of doing this across different data centers in different locations as well. So the challenges of the hybrid cloud. In my experience, I was a part of the acquisition when OVH had acquired vCloud Air from VMware. I think it was this past April they signed the papers and it was a done deal on May 8th this year. So I worked with vCloud Air and got to experience a lot of folks really getting in and diving into this hybrid cloud idea. Began to be a really big deal, and as marketing would have you believe that it's all clear skies, right? It's easy peasy. You have full access to everything that you could ever possibly want or need, and it's simple as a couple button clicks is what you'll find on YouTube or anything like that. But we all know that that's not actually true, and the problem, it's okay, it's just a crummy animation anyways. You'll find out after the fact, after you've already made the commitment, you signed the contract, that, oh, well, I don't have access to that part of the environment. I can't enable this feature on my network or something like that. And then you end up having to compromise your infrastructure and how you planned on designing everything. So I've broken all of these different challenges up into 3 different groups. We'll look at some of the networking pieces on the far left, and then we have our actual setup of the hardware. This is really going to respond to a lot of the colo people out there that need that control. And then finally on the right-hand side, we've got some information on people with what type of experience do you have? Can you troubleshoot these things? Do I want people to telework and do video for projects and things like that? And then ultimately, what type of loss of control and visibility do I get when I have to give my infrastructure up to a cloud provider? Because they're not going to let you take full control over anything because we have to host it to some degree. And ultimately, it just makes your cloud feel like it's a little further away than where it might be. So how OVH can help. First, let's look at latency, bandwidth, security. So these are some of the big things that customers will come up with up front. We have a long-time customer, MIT, and they have a lot of latency-sensitive applications and things like that. So what they have done is spend a lot of time looking at the dependencies in their environment. They use VNRI to check the overall metrics over time and look at reports and figure out what can their applications tolerate before their users start complaining. So from a latency perspective, you can only do so much. We can't make the speed of light faster, so that will always be a player if you're going to have something far away. Some things you can do is try to get a private line, reduce the number of hops between the locations, or there's SD-WAN capabilities to help improve that. From bandwidth perspective, if you're moving up to the cloud, some things you might think of are, am I going to get metered? Is my cloud provider going to start metering how much data I'm sending out? Are they going to cap me when I hit a certain speed? How much do I have to pay for the extra throughput? These are all things that you need to consider when you're moving to the cloud. And then lastly is the security. How am I going to get my users to access this environment? How am I going to connect my on-premise environment to the cloud? Am I just going to use a VPN? How can I make that easy? So OVH's initial answer for that is the fact that we own the backbone. We have the network between all of the data centers, and we've got 32 POPs all over the world. So this is a quick glance at the US. This is what we have here in Europe. And then we also do have a presence in APAC. So each of these pink bubbles here are access out to the internet. The green bubbles you see here are points of presence. So we do allow you to bring your own dedicated circuit to one of these POPs, and you can gain access to your environments through that backbone. And then the dark blue lines are just the connections between the data centers. This is our presence here in APAC. So that's the first part. So secondly, we'll look at something to help continue to address latency. At vCloud Air, we had something a long time ago, for a while at least. It's called HCM, or Hybrid Cloud Manager. You guys might have heard an announcement today during the initial keynote for HCX. That's a rebranding and renaming of this. So we've been doing this for a while now within vCloud Air. And it's pretty impressive what it can do when it comes to helping with migration, connectivity, and the latency pieces. So we have a WAN optimization appliance, which is a part of the fleet in HCM. And what that's going to do is compress the data and run deduplication, so it improves the migration. One of the features of HCM, I'm sorry I don't have a slide for it, is long distance vMotion. And this is regardless of the type of vCenters you have, so they don't need to be the same version on either side. You don't need to do linked mode and share a single SSO domain to make this happen. It'll handle it for you. And something that we're doing between the hybrid cloud gateways when we connect the environments is we actually have set up multiple IPsec tunnels. And then we've taken these multiple tunnels between here. Well, firstly, it serves a purpose of throughput. We need to make sure that we can get a lot of throughput on the virtual machines. So VMware has created this in such a way that with having multiple tunnels and each tunnel being tied to a separate CPU can achieve higher throughputs than just a single tunnel on its own. So we've taken these and we've encapsulated this in a foo tunnel. So it's a UDP encapsulation over the front end, and we have control over the headers and the source port on where that's going to come from. And what that'll do is if you're forcing traffic to go from your on-prem over the internet to your cloud environment, it'll force entropy over the internet because the source ports are different. Each individual tunnel can take a different path over the internet. And what we can do there is probe each tunnel and check to see what the latency is over each individual tunnel. And then we can prefer a particular path over the internet by probing, seeing that, and then sending the traffic over that particular vCPU to help with latency. So increases the throughput. Tunnel can take different paths. Traffic can also fail over. So if there's an issue with the internet itself, because you have different paths to go over the internet, we'll just simply take traffic and start sending it over a different tunnel. Something else that has been implemented in HCM to help with latency is something they've referred to as elephant and mice flows. So the issue is since we have each individual tunnel bound to a vCPU, each of these vCPUs is going to have a queue. So as long as you have the same size traffic and everything is about even, traffic will flow relatively smoothly, no hiccups. The problem comes into play is when you've got one virtual machine that's really hammering this connection. They're sending a lot of data. And what happens is the buffers on that CPU get queued up. So the smaller traffic attempting to go through has to wait as this larger set of data is going through. The problem with that is we introduce latency. So when trying to help with latency by implementing this solution, now we've introduced latency somewhere else. So VMware had to implement some additional intelligence with this. So what we can do is sense when an elephant flow is coming through, and we'll just bond it to that one particular vCPU, and we'll dedicate it to that particular flow of traffic, which prevents this particular issue. So we can still take advantage of the capabilities of the multiple tunnels, and also prevent this issue as well. Something I wanted to mention earlier that I didn't as well is in the WAN opt we are doing, or essentially forwarding additional packets on send. And the reason that this is happening is it's in anticipation of packet loss. And what that'll do is avoid round-trip resends and requests for additional information, which also helps reduce latency. Again, this is being rebranded. It is now HCX. OVH and IBM will be the first to get it. And it can do a lot more than that, but this talk isn't really about HCM, but this should be out very soon. It's great from a layer 2 connectivity standpoint, vMotion to the cloud, as well as it has a lot of DR functionality also. Last thing here is, since we can't bend the laws of physics and really take care of you from a latency standpoint all the way, what we are is very transparent when it comes to how latent we are, our particular data centers, but to other locations. So there's something called smokeping.ovh.net. It's a website we've set up, and we have constant pings going from each individual data center to all sorts of different locations all around the world. So if you know about where you're at, you can choose your source data center that you're looking at, and then choose a destination. And we have these graphs set up so you can see if there's any variance in the latency over time, anything like that. And this is over several days, and this is always subject to change, but it's a good place to get an idea on what's going on. So this is something that we put together just to be as transparent as possible and inform people to make sure that they're making a knowledgeable decision about the location of where their information is going to go or move. Next, we'll take a look at the security and network availability. Something that a lot of the admins I've heard that have been reluctant to moving to the cloud at all is they're afraid that moving to the cloud is going to make them a target or a part of a bigger target, because you have neighbors in the cloud that somebody might want to attack, right? And you could be collateral damage from that if you're sitting there. So that's one of the big things. And then if there is an attack, is network availability. Well, what happens if this neighbor gets attacked and then my cloud provider's infrastructure is overwhelmed, and now I'm also down? So these are two things that we want to look at. OVH, as I mentioned earlier, has its own homegrown solution for anti-DDoS. We did used to use another provider's equipment. We decided that it couldn't scale the way that we wanted to. It couldn't achieve the capabilities of what we had expected from it. So we've built our own. We call this VAC. And the reason we call it VAC is because traffic normally traveling from left to right will go through the two nodes on the top, and we will vacuum this traffic into the VAC system when an attack is sensed. And this is broken up into 4 pieces. So we have a pre-firewall set up first, which is going to be just a preset ACL looking for common ways or common methods of attack. So UDP over port 80 is one that is commonly used. So once this is enabled, we'll be blocking that. The second firewall is actually configurable by customers. So if you want to, you can opt to take a public IP that you've got in the environment and always have it in the VAC system, rather than being pulled when an attack is sensed. If you decide to do that, you have control over a firewall that is specific to that public IP, and then you can add additional rules. So this would help protect your environment before it even hits your external edge to your environment. Second is Shield, which is going to help with most of the UDP types of attacks, filtering all of that. And then lastly, we have Armor, which is going to do the grunt work of actually looking at the behavior of traffic, making sure that we're not getting a ton of duplicates that are pushing through, and overall just preventing that attack from overwhelming your resources. This is all housed in a single data center, right? And we have these in multiple data centers. The reason I bring that up is because we actually can leverage all of them at once during an attack. So by advertising different routes to your infrastructure, if you're under attack, if the attack is large enough, we can pull this traffic in through multiple data centers. Ultimately, you'll stay up. You might see a little bit of increased latency during that time because of the routes that the traffic is taking. But this is great. This is included with your infrastructure, which is pretty impressive. Most other cloud providers are either going to charge you for it, or you're going to have to spend an exorbitant amount of money going to a third-party provider to get this. This is included. There's a quick article at the bottom if you want to take a picture of it. It's really worth the read. Back in October of last year, there was an attack on the east coast of the U.S. It was Dyn. Dyn went down and took out most of the eastern seaboard in terms of connectivity to customers' environments. This was about 1 to 1.2 terabits per second of an attack on dying. A month earlier, OVH was hit directly in France with a 1 terabit per second attack, but you didn't really hear about it because we didn't go down. There wasn't a bunch of customers complaining about, hey, none of my stuff works, and causing a fuss with the media. So unfortunately for us, not everybody knows this, but if you Google it or look that up, there's a ton of information on actually what was happening. Our CEO, Octav, was tweeting about it while it was happening, giving screenshots, pretty impressive stuff. Lastly, we'll move on to design complexity or connectivity and flexibility in the network. So this is, I probably spend more time with customers looking at building a hybrid cloud in this area than anything else. Most other things, eventually they'll accept, okay, well this is an obvious thing I'm going to have to deal with. But this is huge because once you start moving your environment over to the cloud and you want to have hybrid applications, how are they going to talk to each other? And it ends up making things very, very complicated in terms of that. So I have to start re-IPing on-premise to free up different subnets to put those and use those in the cloud. I have to figure out how everything is going to connect. I have to set up my routes between everything. So the design and how everything is connected is a big deal. And then lastly, well, as I continue to either move things to the cloud back and forth, I need to be flexible. Now I have to re-IP again later on, which is a pain. So OVH has something we call VRAC. And what VRAC allows you to do is either between the same data center, you can see the different environments here in Vint Hill. We've got an OpenStack environment, which is the public cloud, and a vSphere as a service, which is our hosted private cloud. I can connect those two together and they can share the same VLAN space, the same 0 through 4092 VLANs. In addition, I can also connect those same networks all the way to Hillsborough or Roubaix. This is not a point-to-point connectivity. This is shared across all of them. And we have VRAC Connect as well, which allows you to bring a dedicated circuit to an OVH POP, and you can simply trunk any VLANs that you would want to send over. There's no other configuration required. Setting this up, you have control over it. You don't have to call us to set up between Roubaix and Hillsborough. You simply just go into a UI and you drag and drop an environment. We handle all the configuration for you, and then you don't have to worry about setting up routes, figuring out connections between the two, making sure that everything is encrypted. It's all going to go through the VRAC, and it's all going to be segregated from everybody else's traffic. We do this. This is a quick rough diagram of kind of how this works and the overall scope of that. So the hosts at the bottom, this is where all your VLAN tagging would be done. As we move up the stack, we'll take the VLANs and we'll encapsulate them in a Q&Q VLAN. And this allows us to segregate customers from each other so they can each have the same 4,000 plus VLANs all the way at the bottom. As we move up, we'll go ahead and take that, remove the Q&Q, and encapsulate that into a VXLAN segment. Move all the way up the stack until we hit the backbone. That VXLAN segment is yours globally. That's essentially, that represents a VRAC, is this VXLAN segment. So you own that across all of your environments. We can send that traffic back and forth as it goes back down the stack. It'll land at the other side, and boom, it's layer 2 over layer 3, which is great. Because of the way we've got this set up, right now we're set up to support 64 billion customer VLANs, global VLANs. This also is included with every environment as well. You do have to order it because we're not just going to burn and give everybody a bunch of VXLAN segments if they're not using it. So you would have to go through and place an order for it, but there's no extra charge to do this and to connect between all of these. Setting it up is really simple. Again, I talked about just a quick drag and drop, and I've actually got a demo of how this works. So in this environment, I've got two different environments in a Canadian data center. If you see at the very top, I've got the vCenter IP ending in 116. And if I go to my other vCenter and I move over, I can see that that's 115. So I've got two different vCenter environments, right? As I go down, I've set up test machines called VRAC test VM. You can see that the IP address, the subnet that this is on, is 192.168.0/24 network. And I've got this tagged on VLAN 10 for this particular NIC on this VM. If I move over to the other, I've got the same network. I've got tagged VLAN 10 as well. And what I'll do here is open up both of these virtual machines. You can see that the IPs are the same. If you look at the title on the top two, it's the same name. And what I'll do is just try to ping between these two. And what you'll notice is that the ping doesn't work. I would skip through a little faster for you guys, sorry. And nothing's going through, so 100% loss of traffic between the two. So what we'll do is we'll go and we'll look at OVH Manager. This is where you manage all of your different environments. This is where you manage VRAC. And on the VRAC section, you can see I've got 4 VRACs deployed, so essentially 4 VNIs. I can see my 116 environment sitting there on one of the VRACs, and if I go to another one, I can see that my vCenter ending in 115 is in this one. So the reason that I can't communicate is because these aren't sitting in the same VRAC. So what I can do is click on that data center and click Move, and simply select the other VRAC that I want this to go into, and hit Move. If you watch the time on the bottom right, you can see I started this at around 11:15 a.m. last month. I do speed this up so I don't have to make you wait the entire time. It takes maybe 3 minutes, 4 minutes. You're not doing anything else other than sitting and waiting. After this is done, you can see it's removed, and then it will also be a part of the VRAC, the destination VRAC that we need it to be in to get communication working. So we see both in the same VRAC. Now if I go back to those same 2 VMs, I don't make any other changes, just hit up and we'll run the same command. You'll see that traffic is now available between these two. So this was an example between 2 data centers or 2 virtual data centers, 2 vSphere as a service environments in the same physical data center. It works the same way to connect between Canada and Roubaix. The video actually goes on longer, and I do the same thing with France. So if you want to go by the booth and see it, you can. But for the sake of time today, we won't show the whole thing. So moving on, let's look at the actual initial setup. So for people looking at building a colo environment, they need full control over everything. What does that mean? So I have to choose the co-location, and then now I have to fly out there, order equipment, have it shipped out there, or I have to hire resources in that area. How long is it going to take me for me to do that? If something happens, how long does it take for me to respond to a failure, order new equipment, fly out there again, get somebody on site? Of course, you could hire someone locally, or you can outsource that service, but again, those are all things you have to think of. OVH's answer to that is how we're automated, right? In Europe right now, we can give you a brand new vSphere as a service environment in roughly 30 minutes. You place an order, we send you an email, you access your new environment. We can add additional resources, add another host within about 5 to 8 minutes. So we've built our own plugins for this. You can simply right click and just add a new host, and you don't have to do anything else. Everything else is fully automated. You can do the same to remove it as well if you're looking at saving. So this is great. If you have a big project coming up and you need to scale up in terms of how much hardware you have, it allows you to be flexible and respond to what you need or what your business needs. I have a quick demo of this as well. This one will be a little shorter. So what I want to do is add a new host. So I'll go into the host and clusters in this environment. I'll choose the cluster that I want to add a host to. And then over on the right-hand side, we can see there's a tab that says Dedicated Cloud OVH. Once I click that, you can see a bunch of different hosts that are or aren't available in that area or region. I'll simply click Order and then End to go ahead and accept that. And that's all I have to do. I've already got my account set up. OVH knows how to bill me. I'll place that order. In a few seconds, you'll notice that a new task gets kicked off within vCenter. And that's OVH working to provision a new host. So what we're doing is we have all of these extra resources sitting on a private VLAN that we manage. We can talk to all of these hosts. During this time, we're actually installing ESX on this host. Before we add it, we have to prep it. So it takes about 5 minutes. This is sped up as well here in a second, so you don't have to watch the whole thing. And you can see over on the left-hand side, at the very bottom, At the about 5-minute mark, we add a host there before it ultimately goes within the cluster. After that, there's some time afterward where NSX has to go ahead and prep the hosts for the VTAP and make sure it's attached to what it needs to continue to communicate. So overall, it took, I think 12 minutes was the total time before it was 100% usable by everything. But OVH had it provided to vCenter, and it was in vCenter's inventory within 5 minutes. I'll just skip that. Next, we'll look at the people. So this is a big deal for folks looking at a new cloud, is do they have the expertise to actually manage this? Have they ever done this before? So a lot of people here, is there anybody a vSphere admin ever used it before? You are at VMworld. But moving to another cloud might not be so easy. I have zero experience with that. So do I have to wait and train these folks before I can continue, which is going to add time? Do I hire somebody new, which is going to cost me money? So that's a big deal. After they get trained on how to just install and configure it, now they also have to know how to troubleshoot and respond to issues. This is going to increase project timelines, or you have to add new people to the environment or train those people. So the big thing here is same tools, same interface. With the vSphere as a service, it's the same thing you're used to. You guys, all your admins should be experts at this stuff by now. You have full access to the vCenter. We expose the API. There are a couple things that we keep. We do retain access or control over the SSO domain and things like that, and we do retain the management networks and stuff like that. But you have full control over managing vMotion, storage vMotion. You can enable fault tolerance on your VMs. DRS, VDS, NSX is fully capable as well. So you can enable and leverage the distributed firewall. You can deploy the edges. So nothing really new here. And then VROPS we have as an add-on as well. So all of these tools are available to you, so it shouldn't slow you down having to learn something entirely new. This is why vCloud Foundation is beginning to be so popular, because everyone's excited to be able to go to the cloud and feel like it's familiar for once. A quick look at the infrastructure itself. So here we can see the customer's resource pool, or your resource pool. This is where the hosts will be delivered and where your storage is sitting. So this is where you have full control over everything. I will want to point out that you'll notice that all the management resources are sitting off in a different box. OVH does not essentially charge you for the overhead to run this infrastructure. A lot of other cloud providers are going to take your vCenter, your NSX manager, and it's all going to sit on your resources, which is a big deal. If you purchase 4 hosts, you effectively have 3 hosts or less, depending on what you've got deployed. So OVH wants to take care of you from that sense. The customer managed networks on the side. On the right-hand side, this is where VRAC sits. So you have full control over that virtual distributed switch. If you want to deploy an IDS, an IPS, anything like that, you need to enable promiscuous mode on a port. You can do that. A lot of cloud providers won't allow you to do that either. I know firsthand, because vCloud Air, we couldn't do it the way that everything was set up. It was just insecure. So customers that wanted to do something like nested labs or anything like that would require promiscuous mode, they had to find different ways of doing it, which greatly limited use cases for customers. So. And for our last bit, we'll look at, again, people, travel and telecommunication, and then we'll spend a second on the loss of control and visibility. So again, full access to your environment. You don't have to worry about traveling to go and deal with that physical server. If you need to log in and get KVM access, it's as simple as clicking a button and having access to that. Because we're a hyperscale provider and because we have massive amounts of resources sitting idle waiting for you guys to purchase, if something happens to a host, anything like that, we'll just add a new one. You don't need to fly out to go replace it in your colo cage, anything like that. From a visibility standpoint, this was a big deal in vCloud Air initially because everything was presented through vCloud Director, which is so far removed from vCenter that you don't have the full metrics of what's going on, anything like that. With OVH, we've actually taken the metrics that can be pulled from vCenter and we've created something called vScope, which allows you to look at all of these metrics in a nice, easy single pane of glass. So this is going to help you look at not just my virtual machine performance and usage, but also the hardware that it's running on. And this is included with every environment that's provisioned. I'll let you take a quick picture of that. From a transparency perspective, this is another issue as well. Since you're up in the cloud and you don't have full control over everything, you don't know what the back-end infrastructure looks like, what the workload is, anything like that. Your hands are tied. Something might be going on. You're having performance issues. You don't see anything on the surface. You open up a case and you sit and you wait. You have no idea. Your curiosity just runs, and then you wait for an RCA or something like that. OVH actually allows you to look into, at a very, very high level, into the data centers, and you can see each one of these little green boxes is a different physical server. So if there is something that's down, it'll be on this page. This is available through our website. You can go to it. You don't need an account to even look at it. If you need to see these later on, if you're interested, you can download this deck through VMware once it's made available. And these are both hyperlinks. The weather map is actually going to show you workload between environments on the network. So you can actually see the load between different environments within, or different areas within the same data center or across between different data centers. So I'm seeing performance issues between two environments in the same data center. Is it maybe a physical issue? This is a good place to look if we haven't already resolved it, or just between two different data centers. You can look here and say, okay, well, there's something going on between these two data centers, obviously, and then you can respond to that until we can take care of it. So overall, the whole point here is you don't really need to compromise when it comes to hybrid cloud, right? We've got a lot of these things taken care of, allowing you to have control, allowing you to meet the needs of your business and respond to that. So I don't have anything else to cover, so this is a great time for Q&A. Does anybody have any questions? There should be someone in the back walking around with a microphone. You have a question here?
So just regarding the storage, what kind of storage are you using? So you mentioned that you have your own server, but what about the storage?
Okay, storage.
I saw vSAN in one slide there, but
yeah, vSAN will be coming out. We don't have it as a service currently. Right now, for like the PCC environments or the private cloud environments, we have our own homegrown solution. It's built on ZFS, which was open source, I think developed by Sun before it was acquired and ruined by Oracle. We call it the Leclerc, which Leclerc is a French tank known for its resiliency and power. So this, I'm surprised I didn't have a slide on that. We've got those set up fully redundant with multiple heads and multiple arrays, so if something goes down, we can take care of that. We do have the ability to Z-motion storage at the storage level, so you don't even see that it's moved between different arrays. So if we need to maintenance that, we take care of that for you. Hopefully that answers some of your questions.
NFS, so what's the problem? So
It's NFS. NFS is what that is. Yes, there you go.
Thank you.
Mm-hmm. I think we do have more information at the booth. If you wanted to come see that, I do have more stuff built out. I just don't have it in this particular slide deck. Yeah.
At the beginning, there was a slide where you showed the bandwidth between your data centers you had. Mm-hmm. Do you have some kind of rule of thumb what kind of bandwidth you need to, or the company needs as an internet connection to use different types of applications smoothly? I mean, there would be high performance applications, not that high performance applications. It's different. Maybe it's, yeah, you need different internet connections.
Mm-hmm. Since we're built for hyperscale, we have to maintain or be conscious of our actual existing utilization and spikes. I think right now we're built up for the 11 terabits per second is a metric on how much we have access to the internet at each location. It doesn't include the actual backbones between them. Right now, we're only seeing maybe 3 to 4 terabits per second overall utilization. So we're definitely prepared to continue bringing people in. We also have a bunch of dark fiber that's not all turned up everywhere as well, ready to go. Once we start seeing that come up, we always have to have some sort of overhead, because otherwise you'll run into a scenario where everybody is suffering from performance issues when that pipe is completely full. Hopefully that kind of answers your question. I don't know if I can give you much more detail.
My question was rather in the way to see, okay, I need to have a connection to your data center. So mm-hmm. I'm connecting via internet, and I have some locations, maybe I have 10 megabytes, 10 10 megabit. Some locations have 100 megabit. Do I need more? Do I need less?
Okay, so
is there a rule of thumb of different applications, what you have maybe?
So from an internet perspective, I know with the private cloud environments, they're coming with either 500 megabit default access to the internet or up to a gigabit in speeds. If you can bring your own dedicated circuit, so if you're worried about communication between environments, like I said earlier, we have all these POPs available. You can buy that dedicated line to come in. I don't think that we have any way to further monitor how much you're using overall. You can, of course, because you'll need to deploy an edge to start, protecting your virtual machines and passing everything through. You can look at that particular edge metric to see what the traffic is over time. I know with NSX you can take a look at how much you're passing through an NSX edge. So that'll give you a good idea over time on what am I actually using. I know from the internet perspective as well, you can take the public IPs that you have deployed, and we do keep some metrics on the public IPs that I think we're expecting to make that available to customers. So this would be a way that you can go and look and see, has there been any attacks on my environment? Like if I see a huge spike, we're not currently reporting or notifying if something has happened. Most customers don't even realize that an attack has happened, which is a failure on our part to show the value in the service. So if you're being attacked and we're protecting you, you don't know, and you haven't realized that you're taking advantage of that. But those would be the two methods of checking to see how much you're using. So you can manage through the virtual edge and look at the metrics on that, or once that other environment pops up, you can plug in the public IP that you're using, and we're tracking just outbound, inbound metrics on that as well.
Thank you.
Any other questions? All right. If you want to contact us, there's some information here. You can take a quick slide or a picture of the slide. We're in booth 313, OVH.com. You can find us on Twitter, Facebook, or LinkedIn. We do have some other sessions this week. I'll let you take a quick snap of that. We do have several other sessions set up this week. Here's their schedule, so if you want to get more information on OVH or what we're doing, these are the topics and what's available. And then the last reminder here is please fill out your surveys. Let us know what you liked, what you didn't, what you would change. It's the only way we'll get better or keep delivering what it is that you're looking for. So thank you guys so much for joining today. I appreciate it.